Day 26, Honors Physics, Problem 43. Here's be a standard ball, or a pretty good bouncing ball. It never bounces at the same height it starts with, but there's a down phase. And once again, clearly thinking about or labeling your points A and B could be helpful here, or would be helpful. So in the down phase, the ball's falling down. You start by dropping it from a certain height, 4 meters, in which case your V initial is 0 from the top spot. It's accelerating down at negative 9.8 meters per second squared, and it's falling 4 meters, so negative 4 meters. So you can figure out V final, which would be as it's hitting the ground. That would be point B. So point A would be where you're dropping it from, and point B would be at ground level. And that would give you the answer to part A of this question. Show the work for that. Now, on the way up, so now we have to reset things. On the way up, the ball starts from the ground level. The ground level would be your point A. That's where V initial is. As the ball's going up, V final will be the top spot. V final will be 0 meters per second. It's going to come to rest, or it's going to stop when it gets to the top spot. So V initial, so we're starting with point A on the bottom. Well, acceleration is still negative 9.8. But S will be positive 3 meters, because the ball will be going from the ground up. So that's a positive 3 meters. And then once you calculate here, this will be the answer for part B. Show work for that. And now, part C, you want the overall average velocity for this total time period. You'll have to go back to both of these parts, the down and the up, and figure out how much time it took to fall during a down phase, how much time it took to fall during the up phase. You could call that I'll call it T down. Have to show work for that. And then T up, show work for that. And then the total time is you add those together. But we want the average, so we want the average velocity, V average, will be the displacement over the total time. Once again, and the displacement here, let's think about this conceptually, will be negative 1 meter. Because the ball started at 4 meters, went down, back up, its displacement, if you look at the beginning point and the ending point, will be negative 1. So S will be negative 1 meter. You'll plug that in for S, the total time being T up plus T down. That will give you an average velocity of a slightly negative number. If you had been asked for the average speed, the total distance over the total time would have been 7 meters over the T up plus the T down. That would have been a larger number because it covered quite a bit of distance in that time, but the average velocity is close to 0 since it didn't really have a great overall displacement.